Hello, welcome to the video lecture on number system part 3. Binary numbers can be represented in signed and unsigned way. Unsigned binary numbers do not have a sign bit, whereas signed binary numbers have a sign bit. The diagrammatic representation for an unsigned binary number is shown here in figure. All the n bits starting from b0 to bn minus 1 represents only the magnitude. There is no sign bit here. The leftmost digit represents the most significant bit. The diagrammatic representation for a signed binary number is shown here in figure. So the leftmost bit represents the sign bit. The remaining bits starting from b0 to bn minus 2 represents the magnitude, and this bit is the most significant bit. The sign bit is 0 for a positive number, it is 1 for a negative number. Unsigned binary number. Unsigned numbers do not have any sign. They contain only the magnitude. So the representation of binary code can be done only for positive numbers. The range of values that can be represented with n bits for an unsigned binary number will be from 0 to 2 power n minus 1. Now let us see how to represent the decimal number in unsigned binary code. So just find the binary equivalent of this decimal number. So this is the unsigned binary code for this decimal number. The same way we can represent this using 8 bits. Just pad zeros here in front. So this is the unsigned binary equivalent of this decimal number. Signed binary numbers. Signed numbers contain a sign bit. So there are 3 different representations for signed binary numbers. First one is sign and magnitude form. Next is 1's complement form, and next is 2's complement form. Sign and magnitude form. For an n bit binary number, 1 bit is reserved for the sign bit. If the value of the sign bit is 0, then the given number will be positive, else it is a negative number. The MSB bit is used for the sign bit, and the remaining n minus 1 bits represents the magnitude. The range of decimal number that can be represented using sign bit will be from minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1. 1's complement code. 1's complement code, we can represent positive and negative numbers using 1's complement code. For positive numbers, the representation is just same as in unsigned binary code. We are going to pad a 0 in front to indicate it is a positive number. To represent negative number in 1's complement form, so we are just going to represent the magnitude, the number in an unsigned binary system. Next we are going to pad a 0 at the leftmost bit, then complement each and every bit. So to convert a binary equivalent to 1's complement form, we have to complement each and every bit separately. So let us see how to convert this binary number to 1's complement. So convert 1's to zeros and zeros to 1's. This is how we convert a binary number to 1's complement form. 2's complement form. Again, positive numbers, they are represented in the same way as in unsigned binary code. We are going to pad a 0 in front to indicate it is a positive number. To represent a negative number in 2's complement, we are going to represent the magnitude just in an unsigned binary code. Just convert the given number to its binary equivalent. Then pad a leftmost 0 to the leftmost position. Then find 1's complement of the given number. Then add 1 to it. This is how we find 2's complement of a number. So let us see how to find 2's complement of this number. So first find 1's complement of it. Means we are going to complement each and every bit. Then add 1 to it. So to find 2's complement, first find 1's complement, then add 1 to it. So now we'll see how to represent plus 18 and minus 18 in signed bit format. So plus 18, since it is a positive number, the representation is same in all the 3 representations. So the leftmost bit represents the sign bit. This is 0 to indicate this number is a positive number. And this represents a binary equivalent of plus 18. The same way negative number can be represented in 3 representations. First is sign magnitude form. The leftmost bit is 1 to indicate that it is a negative number. The remaining bits are just the binary equivalent of plus 18. To represent minus 18 in 1's complement form, the leftmost bit is 1 to indicate it is a negative number. We have to complement each and every bit. So convert 1's to zeros and zeros to 1's. This is the 1's complement representation of minus 18. Now 2's complement representation of minus 18. So the leftmost bit is sign bit. It is made 1 to indicate it is a negative number. So then what we are going to do is we are going to first find 1's complement of this. Then we are going to add 1 to it. So that is the 2's complement of plus 18. So this is how a negative number can be represented in all 3 representations. 1's complement subtraction. Subtraction of a binary number using 1's complement method allows subtraction only by addition. To subtract a smaller number from a larger number, we are going to follow three methods. First one, we are going to determine 1's complement of a smaller number. Then we are going to add this to the larger number. Then we are going to remove the carry and add it to the result. This carry is called as an end around carry. Now we'll see a simple example how to subtract 1010 from 111 using 1's complement method. So this number is written as such. 1111 is written as such. Now we are going to take 1's complement of this number, which means we are going to convert 1's to zeros and zeros to 1. And now these two are added. So we will get a carry. This carry is taken and this is added to the result. This carry we call it to be the end around carry. This is added to the result. So the final answer is 0101. 1's complement subtraction. Next we will see how to subtract a larger number from a smaller number. First we are going to determine 1's complement of the larger number. Then we are going to add this to the smaller number. The answer is in 1's complement of the true result and is opposite in sign. There is no carry. Now we see an example how to subtract 1010 from 1000. So this number is written as such. So this is converted to 1's complement. 1's complement of this one will be 0101. Now these two are added. So this will be the result. There is no carry. So now we are going to take 1's complement of this one. 1's complement of this one will be 0010. 2's complement subtraction. The 2's complement of a binary number subtraction is obtained by following these methods. First we are going to see how to subtract a smaller number from a larger number. First determine the 2's complement of the smaller number. Then add this to the larger number. So then we will have a carry. We have to discard this carry. Now we will see how to subtract 1010 from 1111. So this number is written as such. 1111 is written as such. Now we are going to find 2's complement of this number. First find 1's complement of this, then add 1 to it. So this is the 2's complement of this number. These two are added. So we will always have a carry. So this carry is discarded. This is taken as an answer. Answer is 0101. Next we will see 2's complement subtraction. So wherein we are going to subtract a larger number from a smaller number by following these three methods. First determine the 2's complement of the larger number. Then add the 2's complements to the smaller number. There will be no carry. The result is in 2's complement form and is negative. To get an answer in true form, take the 2's complement and change the sign. Now we'll see how to subtract 1010 from 1000. So 1000 is taken as such. Now we need to find 2's complement of this. So 2's complement of this can be obtained by first taking 1's complement and then adding 1 to it. So this is the 2's complement of this number. So we are going to add these two numbers. There will be no carry. So this is in 2's complement form. So to get in true form, we have to find 2's complement of this one. So first find 1's complement. Change 1 to 0, zeros to 1. Then add 1 to it. This is the result. Change the sign. Next we will see how to perform addition using 2's complement method. So here, this is the augend and this is the addend. We are going to consider both numbers are positive numbers. Positive numbers are to be added. Both the augend and addend are positive here. So since both the numbers are positive, the binary representation of this is shown here. The binary representation of 19 is given here. The leftmost bit is sign bit, it is 0. Normal addition is carried out. Leftmost bit is the sign bit. So the decimal equivalent of this is taken, which is equal to 48. Next we will see how to add a positive augend number and a negative addend number. Augend number is positive and the addend number is now negative. Since this is a positive number, so just take the binary equivalent of this number. The sign bit is 0 to indicate this is a positive number. So this is a negative number. To find the 2's complement of this negative number. This is the 2's complement of 22. So now add these two. You will get a sign bit and the carry bit. So carry bit is omitted. And then the result is 001 001, which is equivalent to 17 in decimal. Next we will see how to add a negative augend number with a positive addend number. So since this is a negative number, this is represented in 2's complement form. This is a positive number, this is just the binary equivalent of plus 29. So now these two are added. We get a sign bit. Sign bit is 1, which indicates this is a negative number. So since this is a negative number, we have to find 2's complement of this number. To find 2's complement, first I find 1's complement. Then I add 1 to it. So this is the 2's complement. Since the sign bit is 1, we put a minus sign here. So the answer is minus 18. Next we will see how to add two negative numbers. The augend is negative and the addend is also negative. Since both the numbers are negative, they both are represented in 2's complement form. So this is the 2's complement of 32. This is the 2's complement of 44. So now these two are added. We get both carry and sign bit. Carry bit is omitted. So since the sign bit is 1, it indicates this is a negative number. So now we are going to find 2's complement of this number. First find 1's complement of it, add 1 to it. So we get 2's complement. So the decimal equivalent of this is 76. Change the sign. Next we will see subtraction in 2's complement form. Again here both the numbers are positive numbers. We are going to subtract 19 from 28. So this is a positive number, this is also a positive number. So consider the case where 19 is to be subtracted from 28. So the binary equivalent of 28 is written here, binary equivalent of 19 is written here. Since we are going to subtract 19 from 28, the system will send this plus 19 to a 2's complement circuit. So we are going to find 2's complement of plus 19. So this is the 2's complement of 19. So now this 28 is added with minus 19 now. So we will get a carry. Now carry is omitted and the decimal equivalent of this number is 9. This is our answer. Next case we are going to consider a positive number and a smaller negative number. So here the minuend is 39 and suprahend is a negative number minus 20, and this is minuend and this is suprahend. So minuend is positive, suprahend is negative now. So since this is a positive number, so this number is represented in binary form. Since this is a negative number, this is represented in 2's complement form. Since we are going to subtract, this will be given to a 2's complement circuit. Which means we have to find 2's complement again to this number. So 2's complement of this number is this. So now plus 39 is added with this number. So this is the answer. Since this is a positive number, sign bit is 0. The decimal equivalent of this is 60. Next third case, we see the minuend is positive and the suprahend is negative. Minuend positive, suprahend is negative. Since this is a positive number, the binary equivalent of this is written here. Since this is a negative number, this number is represented in 2's complement form. Now we are going to subtract this from this. So this is given to a 2's complement circuit. So we are going to find 2's complement of this number. So which is nothing but 2's complement is written here. So now plus 19 is added with this number here. So the sign bit indicates this is a positive. So the decimal equivalent of this is taken, which is equal to 62. Next we are going to consider two negative numbers. The minuend is also negative, suprahend is also negative here. Since both the numbers are negative, so this is written in 2's complement form. This is also written in 2's complement form. So now this has to be subtracted from this. So this is given to a 2's complement circuit. We are going to find 2's complement of this one. So 2's complement of this number is this. Now minus 57 is added with this. So this indicates the sign bit is negative here. Sign bit is negative, so this indicates this is a negative number. So now we have to find 2's complement of this negative number. So first find 1's complement, then add 1 to it. Then find the decimal equivalent of it, then change the sign. So the answer is minus 24. An overflow. Overflow occurs when addition of two positive numbers results in a negative value or the subtraction results in a positive value. So when we add two positive numbers, then the result is negative, or when we add two negative numbers, then the result is positive, then the overflow occurs. So an overflow is a software problem and it is not a hardware problem. In digital computers, an overflow occurs when an operation results in a quantity beyond the capacity of the storage register. Thank you for watching this video.